Station, this is Houston. Are you ready for the event?
We are ready for the event.
Associated Press, this is Mission Control Houston. Please call station for a voice check.
Station, this is Marcia Dunn with the Associated Press. How do you hear me?
Hello, Marcia. We have you loud and clear. Good to talk to you today.
Well, good morning from the Kennedy Space Center. I'd like to start off by welcoming Kate to space and directing my first several questions to her, if you don't mind. Tell me a bit about the ride up last week, Kate, and your time so far at the space station. Is space how you thought it would be?
Great question. We spend a lot of time preparing for launch, obviously. It's been about a 2.5-year training flow, and you hear a lot about launch, but there's nothing really that can quite prepare you for the actual event of a ride on a rocket. So it was an amazing launch. All the folks on the ground said that it was beautiful to see, and for me, one of the most amazing parts has been opening the hatch and getting to glimpse the space station for the first time.
Well, correct me if I'm wrong, but I believe you are the first professional virus hunter to fly in space, and there's a lot of interest down here in the DNA sequencer launching next week on the SpaceX Dragon. Can you tell me about the device and how and when you plan to use it and what samples you'll be testing?
Yeah, it's an example of some of the really exciting technology development and also life sciences microbiological experiments that we're doing on station. It's going to be launching on SpaceX coming up pretty soon, and we're really interested in how this works in microgravity. It's never been done before. We're going to be trying to do the first DNA sequencing in space, and it'll be a combination of a bacteria, a virus, and a mouse genome that we'll be sequencing.
Certainly, you've worked with a lot of dangerous viruses on Earth, and I'm assuming nothing is coming up to the space station that's going to equal that. But what is the deadliest, most infectious virus you've worked with on Earth? And by comparison, do you think your work up there is going to be much easier, at least less stressful, at the very least?
Yeah, we've got a lot of safety folks on the ground making sure that nothing dangerous gets on board, and we really appreciate the work that those guys do. So everything that we send up is not pathogenic to humans and has been really carefully tested. On the ground, my previous work was definitely in more of the dangerous pathogen area. We worked on Ebola, smallpox, Marburg, and Lassa virus. And those are diseases that are definitely affecting human populations on Earth. And so doing the work on that was important. It is stressful to work in a dangerous environment, but we feel like the training really takes care of a lot of the uncertainty of the situation and our ability to respond to a dangerous environment, whether it's in a biosafety level lab on the ground or on space station. We've got a lot of good folks working to help us out, and we do have quite a lot of training and preparation to get us here.
What about previous DNA research done in space? Tell me what's been done so far in space, and how is the sequencer going to expand the genetic envelope, so to speak?
Yeah, so Jeff actually did a couple of great experiments early on Expedition 47. One of them was an experiment called Genes in Space, which was a high school competition, and it was a PCR machine, so it was designed to detect specific DNA sequences. There's also a great experiment called Wet Lab, which is a different kind of PCR machine that allows you to see in real time what the genetic results are on board Space Station. And those are looking for specific sequences. The biomolecule sequencer that we're going to be taking a look at is actually going to look at everything in a sample. So it's a way of looking globally at what's going on in a sample versus going in and looking at individual genes. Altogether, it's an extremely exciting research package and a great capability on board station.
Well, there's so much talk about going to Mars. How might that benefit a Mars crew?
Well, anything that we do on Space Station is helping us understand how human beings can live in space. And so the kind of work that we'd be doing with the sequencer is just going to understand the general process of things like bone loss and microbial changes on board Space Station. But it also actually has a benefit for the Earth-based research as well. When we do things in a remote environment up here, we can understand how these technologies might work in remote places on Earth that don't have access to good medical care. So it's got an exploration goal, but it also definitely really, I think, has a Earth research benefit as well.
And one last question to you along these lines before I talk to Jeff. You know, how germy is the space station? You know, I mean, you're a professional here. What's your take on it without getting out all the scientific equipment? You know, we've heard about the microbes up there. Is it a worry in your mind?
No, I think we've demonstrated that human beings can live in space for 15 years now. We've had a continuous human presence on board the space station. I think it's a really interesting question from a research perspective, what's going on in the microbial world around us. We know we have microbes inside and outside the human body that are living along with us, and so the chance to see how those behave in microgravity is going to be a really interesting question on board Space Station in the coming years.
Jeff, you know, the Dragon, of course, is going to be flying up next week. How important is it to get this docking adapter up there safe and sound? We all remember what happened to the first adapter last summer.
Well, of course, it's very important. It is required in order to have the commercial crewed vehicles that are currently in development be able to dock to the space station. So it's in the critical path to the future of the exploitation of the International Space Station.
Do you see two as being necessary before the first crew flight by either Dragon or the Starliner? I mean, or do you think one would suffice at least for a short period?
Well, you know that virtually everything we do has redundancy in it, and having two on board gives us that redundancy. So I think what the current thinking is that we need to have two on board before that first launch, for that obvious reason of redundancy.
Thanks for that answer. And 5 years ago these days, Atlantis was making the final shuttle flight. What's your thoughts, Jeff, on this 50th anniversary of the last shuttle voyage? And do you feel a bit of melancholy still over the end of the shuttle program, or are you looking more to the future at this point and what that might hold?
I'm looking more to the future. You know, if you look at it historically, the shuttle-like vehicle was first envisioned as early as the 50s, the mid and late 50s. And it was developed in the 70s, and we went through the 80s largely forgetting what it was developed for. But the primary purpose was to put up a space station piece by piece. And in 1984, of course, President Reagan announced Space Station Freedom, which never really coalesced in terms of the political support to launch it. But then we morphed into the International Space Station in the early 90s, bringing the Russians on board as a partner, and then finally began launching elements in 1998. And finished it out, as you said, 5 years ago with the flight of the shuttle. Now, the early cancellation of the shuttle, of course, was driven largely by circumstances surrounding the Columbia accident and the hard decisions that had to be made after the Columbia accident. As you know, the shuttle was originally envisioned to continue to fly for the life of the space station, to support it, and that decision was made to retire early. It was tough for everybody to retire the shuttle. It was a great vehicle and did its job, but that's the point. It did its primary job. It fulfilled its primary purpose, and the teams did a great job of adjusting so that we could continue to fly out the space station for an extended period of time without the shuttle, using other vehicles, and then also using it as an opportunity, as a destination, if you will, for these new developed commercial crew vehicles.
Yes, Jeff, and congratulations in advance on your record that you'll be breaking with the accumulative U.S. time. Does a year and a half in space, even if it's cobbled together over several flights, feel long to you? And I'm afraid I'm going to have to sign off after that question, so Godspeed to you both.
Thank you very much, Marcia. Great to talk to you.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Associated Press. Station, please stand by while we configure video and audio communications.